welcome back. So I'm going to be explaining resolving forces. It's part of the forces and their interactions topic. It's hard, maybe level kind of 7, 8, 9 stuff. So do what you can, but don't overwhelmingly panic about it. So when we're drawing vector diagrams here, we need to be able to draw them to scale. So as in I say 1 centimetre is 1 Newton. If you have a question on this in the exam, they give you a bit of graph paper. It's easier to do it on graph paper because you can set your scale. But you don't have to use graph paper, but you do need a ruler and you do need a protractor to measure and draw the angles. And it is so much better to do it in pencil in case you make silly mistakes. If I made a mistake, I just did it again. So first thing you need to be able to do is resolving forces. So this is 5 newtons acting at 40 degrees to the horizontal, and it is exactly the same, it has the same effect as these two forces here. Any force can be resolved into its vertical and horizontal components. So this force here is the same as these two forces, 3.2 newtons vertically, 3.8 newtons horizontally. Now, you find these horizontal and vertical components by doing the following. So this is a bit different. I've got 7 newtons, 32 degrees. So I actually measured that angle, 32 degrees, and that arrow is 7 centimeters long, 7 newtons. I then kind of like draw myself vertical and horizontal sections, which I did in pink. And then you kind of draw an arrow down, straight down, draw a little line straight down, and where it hits your vertical here, kind of like to make the triangle, if you like, sort of, then this arrow here along the bottom is your horizontal component. I measured it, it was 5.9 centimeters, so it's 5.9 newtons. This arrow up here is the vertical component. I measured it, it was 3.7 centimeters, so it's 3.7 newtons. So you just draw your force, you take a line down, take a line across, and then those are your two arrows. So this 7 Newton force acting at 32 degrees is the same as these two forces, has the same effect. So I've resolved it. The second thing you need to be able to do is work out if something is in equilibrium or not. So I've got 3 forces acting here, 3 newtons, 4 newtons, 5 newtons, and I want to know if this object is balanced or if it is going to move. So for this, what I need to do is I need to redraw these arrows, but instead of drawing them like this as a free body force diagram, I'm going to draw them head to tail like this. So I'm going to draw them in a little row, but at their correct angles. So first one I drew was a 3 newtons, because that one's acting upwards. Then I draw the second one, 4 newtons ones. It doesn't matter what order you do them in. It really doesn't. I could have done the 5 Newton ones here, the 4 Newton ones would have been there. So long as I'm drawing them top to tail, it doesn't matter which one you start with, which one you finish with. So you pick one, you draw it, you draw the second one head to tail, you draw the third one head to tail. And if they close shape like this, and you get a nice close shape, a triangle or a parallelogram or whatever, it means, yeah, they're balanced. Yeah. And then the last thing you need to be able to do with vector diagrams is find the resultant force. So say I've got 2 forces acting here, 5 newtons and 4 newtons. The 5 newtons is at 43 degrees to the horizontal and the 4 newtons is horizontal. I'm going to again redraw them head to tail. So it doesn't matter which one you draw first, as long as you redraw them head to tail, and the resultant force is the one that kind of could take the place of your 2's drawn head to tail. It's a bit like this. It's like the opposite of this one here. I'm trying to find one force that replaces these 2 forces. So I draw my 4 newtons along here. Again, 4 centimeters. Then I draw my 5 Newton arrow, 5 centimeters at 43 degrees to the horizontal. And then what I do is I draw an arrow that goes, these are head to tail, and then I want to draw another arrow that goes, starts at the same place that I started and finishes at the same place that I finished. And it's sort of like, if you think about of walking, I could walk along here and up there, or I could just take this shortcut here, and this shortcut does the same job. And this arrow here, it was 8.5 centimeters long, so it's 8.5 newtons, and I measured the angle to be 25 degrees to the horizontal. And this is the resultant force from these 2 forces. Now, just a word, you can do all this, most of it, using trigonometry. Some of you might have noticed that this was obviously going to be a 3, 4, 5 Pythagorean triangle. You can use it using trigonometry, but for the GCSE, you need to be able to do it using vector diagrams. They're not interested in your ability to use trigonometry. You have to use vector diagrams. Now, that said, sometimes if you get the correct answer, yeah, you might get all the marks, but there'll be working marks, and you need to know how to do this. And if you just kind of plug it into your calculator and come up with the resultant force, you're not going to get all the working marks. So please do it like this. I know this is complicated, but like I say, this only comes up at the real higher levels of these papers.